Okay, here we have page 2 of the polar coordinates review sheet. So much like we did on the previous page on number 9, first thing we're going to do here is we're going to expand this. And again, this is rectangular equation. We're going to change it to polar equation. So expand this out and gets x squared minus 6x plus 9, and then plus y squared plus 2y plus 2 equals 10, not plus 2, plus 1 equals 10. So we have to be able to expand. All right, now again, we're going to subtract 9 and subtract 1 from this side, minus 9, minus 1. So this now gives us x squared minus 6x plus y squared plus 2y equals 0. Put our x squared plus y squared together, minus 6x plus 2y equals 0. Now we're going to substitute x squared plus y squared with r squared, and then we're going to substitute x with r times cosine theta, and we're going to substitute y with r times sine theta, and that equals 0. And then once again, I'm going to take my negative 6r cosine and I'm going to bring it over here. I'm going to do the same thing with my 2r sine theta. I'm going to bring it over here. So I'll rewrite this equation. It's going to be r squared equals 6r cosine theta minus, so I brought it over, minus 2r sine theta. Come in here, divide everything by r, and it leaves my answer with r equals 6 cosine theta minus 2 sine theta. All right, number 12. Again, we use the fact that x equals r cosine theta and y equals r sine theta. So I'm going to rewrite this equation. So this equation here is the same as saying y equals negative root 3 over 3x. Okay, so let's rewrite that. R sine theta equals negative root 3 over 3 times r cosine theta. Okay, come through here and divide both sides by r cosine theta. R cosine theta. The r's are going to cancel out. Well, first of all, that cancels out. These r's cancel out. Leaves me with sine theta over cosine theta equals negative root 3 over 3. I've got to remember so this is tangent theta equals negative root 3 over 3. And again, we'll have to remember my unit circle, but theta equals arctangent of negative root 3 over 3. I've got a couple choices for that. I have 5 pi over 6 right here, 5 pi over 6, and I also have 11 pi over 6. Okay. However, let's go back to our original problem here where y is positive, x is negative. So in the second quadrant, x is negative and y is positive. So I'm going to have theta equals 5 pi over 6. This would be the polar equation that equates to this this linear equation. So this linear equation is a straight line, but with a slope of negative root 3 over 3. This would be the polar equivalent of it, just theta equals 5 pi over 6. All right, now we're going to convert each equation from polar to rectangular form. So now I want, instead of everything being in terms of r And theta, I think I need everything in terms of x and y. Let's see. We know that tangent of theta equals y over x. So we're going to replace tangent of theta with y over x. Y over x equals 2. Solve for y. Y equals 2x. There's my equation. Basically a line. Okay, this one's a little trickier here. The best way to think about it is you come back to this problem here that we did, and you kind of reverse engineer it. You kind of start from what we ended here and go backwards. So if we remember, the last thing we did up on this equation is we divided out by r because we had an r square. So over here, what we're going to do is we're actually going to multiply everything here by r. So we have r squared equals negative 6r cosine theta plus 2r sine theta. As long as we do it on both sides of the equal sign, then it's okay. All right. We're going to now bring everything over to one side. So we have r squared minus 6 r cosine theta plus 2. Oh, whoops. Oh, I'm bringing them over. Come on, Kevin. Let's get this right. R plus 6 times r cosine theta. 2 minus 2r sine theta. All right, well, r squared is the same as x squared plus y squared. R cosine theta is the same as x, so this would be plus 6x. R sine theta is the same as y, so that's y equals 0. This should have been equal 0. All right, now we're going to bring, get all the like terms together. X squared plus 6x plus y squared minus 2y equals 0. I left these gaps here because we need to complete the square. 6 divided by 2 is 3. 3 squared is 9, so that's plus 9. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1, so this is plus 1. I'm going to add 9, and I'm going to add 1. My final equation then, complete the square. Square x plus 3 squared plus y minus 1 squared equals 10. So you can see how, in this case, we basically, again, we just sort of reverse engineered what we did there. All right. Number 15 does the same thing. We're going to multiply this side by r. It's easier right this way. We're going to multiply everything by r. So r squared equals negative 2r cosine theta plus 6r sine theta. Why don't we make it easy on ourselves before we ever change this? Go x squared plus y squared equals negative 2x plus 6y. Bring these over. Bring that stuff over. X squared plus 2x plus something plus y squared minus 6y plus something equals 0. That something is when we complete the square. 2 divided by 2 is 1. 1 squared is 1, so that's 1. 1. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9 plus 9. So I'm going to have x plus 1 squared plus y minus 3 squared equals negative 10. Okay, if you don't know these steps for doing complete the square, I don't know what to tell you. At this point, you have to know it. Okay, this one, there's a couple different ways you could probably do it. I'm going to start off by, dividing both sides by that the best way to do it? Let me leave it. No, let's do this. We'll do a bunch of different ways. Cosecant theta, cosecant theta, cosecant. So I have r over cosecant theta equals cotangent theta. Cosecant theta, that would be the same as r times sine theta equals cotangent theta would be cosine theta over sine theta. Okay, now I'm going to use the fact that r sine theta equals y, and the fact that cosine theta equals x over r, sine theta equals y over r. So I'm going to r sine theta equals y, cosine theta equals x over r, and sine theta equals y over r. Y equals x over r times r over y, solving for this. That's same as that. So the r's cancel out. Leaves me with y equals x over y. Solve for y, y squared equals x. Okay, the last two are super simple. But just have to remember, we're plotting a point. We first look at the angle. So let's go find that angle. Do it in red, we'll come up here. There it is. And then we look at our r. We say, okay, where's r? 4. So we start from the middle, we go 1, 2, 3, 4. And this would be that point. All right, coming over here. Again, first look for the angle. 3 pi over 4. 3 pi over 4. Pi over 4. 2 pi over 4. 3 pi over 4. 3 pi over 4. And then we count 1, 2. Okay. So these were kind of overtly simple plots. We didn't have to reflect over. I want to look at that really quick. Let's say this angle instead was, let's say this was -2, 3 pi over 4. If that were the case, we'd first go look for 3 pi over 4, and then it's -2, so we'd have to reflect over our polar coordinate. Okay, we'd have to reflect over this polar coordinate, or the pole, sorry. So we reflect over that. So we find our angle and we reflect over it. And so instead of being 2 there, it would come over to the other side. It would be 1, 2 here. So this is a point -2, 3 pi over 4.